So our first learning goal today is being able to, it says over here, I can put values into what? Harley? That's what it is, right, exactly what. So I need you to be focused here. Our first learning goal over here is I can put values into a what class? Function tables to analyze relationships. So that's the first thing we're going to do is we're going to be taking some input values, putting them into the table and getting the outputs for them. And then we're going to analyze the thing again by talking about what are the, what's dependent upon what, which we kind of started talking about yesterday. So let's just dive right into number one here. Suppose strawberries cost $3 per pound. How much does it cost for 5 pounds of strawberries? So we're going to, we need 5. Would it make any sense to have any negative input values? No. The number of pounds, could we have a negative number of pounds? No, and we're not even going to probably have 0. So since there's 5 spaces in here, let's use 1 through 5. Because in the end, they want us to have the answer for 5 pounds. Okay, so what are we going to have to do to those input values to get our outputs? Remember we talked about this yesterday. We already had the input tables, and we had to, they were the input and the outputs there. And we had to figure out what got done to the input to get the output. So now today, we have to get the outputs. So we're also going to have to determine what to do to the input from the information they gave us. Suppose strawberries cost $3 per pound. How are we going to get the output? Jen? Times 3. We're going to take the number of pounds times 3. So let's go over here to the side and do that. And the results we get for those products are going to be in the cost in dollars column. The output. So 1 times 3 is 3. 2 times 3 is 6. Our 3 times 3 is 9. Our 4 times 3 is 12. And our 5 times 3 is 15. What's happening? It just keeps going up by $3, right? For every pound of extra, another pound of strawberries bought, the cost goes up $3 more, doesn't it? Okay, let's talk about the relation. Oh, let's answer that question. How much does it cost for 5 pounds of strawberries? $15, we found out. $15 for 5 pounds of strawberries. Okay. Now let's fill in the, what were the unknowns in this? Which one is in control? That's the input. Which one is the result of it? That's the output. So, what depends on what? What do you think? What depends on what? Come on. This is yesterday. We did this, I don't know how many times yesterday. Well, the 2 unknowns are the number of pounds of strawberries and the total cost. So Sam, what do you think?
The cost depends on
Yeah, the total cost. So we're going to say the total cost and the reason we say total is because there's a cost per pound involved in this problem, isn't there? So our output column depends on how many pounds we bought, right? Because that's what we were doing. We were taking the number of pounds of strawberries. So the total cost depends on the number of pounds of strawberries. The output depends on the input. Okay, in this next one, let's figure out the relationship first. Figure out the relationship first. What are the 2 unknowns in this one? Or the things that can change, basically? in number 2? Well, you're not gonna find the answer on me, so don't look at me. Either use the whiteboard, the smartboard, or use your paper in number 2. What are the unknowns? What are the things that can change in this problem? I know, I should have do right here. What are the unknowns in number 2? Pardon? Okay, well, yeah, the $4 per gallon is set. And they just happen to want to know how much for 10 gallons of gasoline. But what are the things that can change, Kate? The number of gallons of gasoline that you're going to get. And what's the other? Kate? The total cost in dollars. How much is it going to cost you altogether after you buy so many gallons of gasoline? So what are we going to put first then? Are the number of gallons of gasoline going to depend on the total cost? Or is the total cost of the gas going to depend on the number of gallons of gas? What do you think, Tyler? Yeah, the total cost of gas. Again, not just cost, because we already know that there's another cost involved in this, and that's the price per gallon. So the total cost of gas depends on the number of gallons of gasoline. So the output depends on the input. What's our input? What's the input? Here's one thing that they do in tables. They put the input here in the first column, and they put the output in the other column. So our input is what? The number of gallons. Okay, well, since they want to know for 10 gallons, we'd like that 10 to be in our table. So let's go by 2s in this one instead of by 1s. Let's start at 2. And that should take us up to 10, shouldn't it? Okay. What do we have to do to our inputs? 2, 4, 6, 8, and 10. What do we have to do to those to get our outputs? What do we have to do? Katie? Take them times 2? Why times 2, Katie? So it's $4 per gallon, so we should take it times 2. No.
Times 2 is 4.
0, what should we take it times? We should add. What should we add?
2.
2? Okay, why should we add 2?
Because 2 plus 2 is 4.
Okay, but what are these guys, these numbers over here representing, class? 2, 4, 6, 8, and 10. What are they representing again? Well, yeah, they're even numbers, but what are they representing? Tyler? Take it times 10. Okay. Why would we take it times 10? Okay, maybe we gotta go back and answer this question. What's that 2, 4, 6, 8, and 10 representing? Gallons, the number of gallons of gas. And the output is the total cost. So what are we gonna have to take times the number of gallons to get the total cost? Times 4. It's $4 for every gallon you buy. So if we buy 2 gallons, we have to multiply by 4. And what do we get? 8. If it's 4 gallons, we have to multiply by 4, the price per gallon. 4 gallons at $4 a gallon is 16. 6 times 4 is, what's up, Arlie?
But it says charges $4 per gallon of gas.
$4 per gallon, that's right.
So then when the first one is 4 then, says 2 gallons for $4.
It's per gallon, that's per 1 gallon. And we're buying, in the first input, we're buying 2 gallons. So we have to pay $4 twice, don't we? Yeah. What's 6 times 4? 24. What's 8 times 4? 32. What's 10 times 4? 40. Okay. Now, we have to answer that question yet. How much does it cost for 10 gallons of gas? $40. $40. Okay. We're still kind of at that, stage of, you know what? We don't know what to do with the numbers they give us. We have to think through the process. You cannot just be like, oh, well, I'll just, I gotta use 4, I gotta use 10 somewhere, I gotta whatever. Just, we have to think through what's actually happening. Okay, let's go to the back side and do a couple more. We do need the practice. So, here's Elizabeth. She's making $10 an hour for babysitting. If Elizabeth babysits 6 hours, how much does she make? Okay, what's the input and what's the output in this problem? What's the input? What's in control? Oh, Kate, you can't answer everything. These other deadbeats have to wake up here. I'm sorry if I offended you, but that wasn't very nice, was it? Well, I'll have to agree with that. What could be the input and what could be the output? They almost spell it out for you guys. If you would listen to what I say previously, flip over to the other side. What did I say they usually put first in the table? The inputs. And then the other column is the output. Well, jeepers, I think they might have almost set it up for you. Derek?
Is it 10 to the number of hours?
The what is the number of hours? The input?
Yeah.
Yeah, okay. So in other words, let's put an input above here. If we put in the number of hours, if we do something to the number of hours, the result should be what? The output. And what is the output? How much she makes, yeah. How much Elizabeth is going to, the total amount of money Elizabeth is going to make. So, let's go over here and fill this out. The what depends on the what. Let me remind you, it's like this. The output depends on the input. Tyler? Yeah, we're going to say the total, the payment. We get lots of room here. Let's say the total amount, total payment, the total amount Elizabeth makes the total amount Elizabeth makes depends on what? Number of hours she babysits, yeah. Okay, well, if the total amount she's going to make, the output, is going to be the result of the number of hours she babysits, what do we have to do to that input, those hours? What do we have to do to them? Any ideas what we're going to do? Okay, well, let's pick some numbers then. Number of hours. Well, they want to know if Elizabeth babysits 6 hours. So should we do evens again? Okay. 2, 4, 6, 8, 10. What do we have to do to that we also do to 4, that we also do to 6, that we do to 8, that we do to 10? Wait. Multiply by 10 because that's how much she gets paid for each hour, right? Yeah. Each hour she makes $10. So if she works 2 hours, she makes $20. If she babysits 4 hours, she makes $40. If she babysits 6 hours, she makes 60. It seems to be going up by 20 because our hours are going up by 2, and 2 times 10 is 20, so that makes sense that this should be climbing by 20s if the hours are climbing by 2s. Okay, what's the answer to our question? If Elizabeth babysits 6 hours, how much does she make? $60. Gosh, I wish I would have made that kind of money when I was babysitting. I made 50 cents an hour. How much would I have made for 6 hours? Seriously, I made 50 cents an hour back in the day when I babysat. 6 hours of babysitting at 50 cents an hour, how much would I have made? 50 plus 50 is $1. Another 2 hours makes another $1. Another 2 hours makes another $1. How much money do I make? I made 60. I was, like I said, I wish I was. I know. 2 hours makes $1. 2 more hours makes another $1. 2 more hours makes another $1. I made $3 for 6 hours of babysitting. Oh, wow. Okay, let's go to number 4. Yeah, possibly. You know what? I think we are actually going to skip this one. I think we can. Hopefully, we are able to not do this one and move on to our next thing we need to do because I know we are going to need time for it, lots of time for it. So let's skip that one. You guys got this? Do you got this?
Yes.
Derek does. Lee says sure, that means maybe. Just tell her what she wants to hear. You know? Okay, here's the next one. And you're going to need one more handout, which is this one. So put these side by side. We're going to work with these two together. Side by side. And then at the end, remind me to send staplers around to staple all this stuff together so we have it. Okay, this is all on top of it. Okay. Okay. So we are going to the other learning goal says, I can translate shapes on a coordinate plane. So looking at the handout I just gave you that has the coordinate planes on it, and number 1, what kind of shape are we going to translate? It looks like it might be a square. Count the squares and see if it really is a square. Is it a square? Is it what by what? 4 by 4, isn't it? Yeah, it's a 4 by 4 square. Okay, so we're going to translate that square. Over here, it says, okay, I want you to verify, is this what's graphed on their report? Do they have point A at negative 8.6? Point B is at negative 4.6? Okay. Point C is at negative 4.2? And D is at negative 8.2? Okay, so that's the original shape. We're going to translate it, and when we transform, there are lots of different types of transformations. There's translations. Anybody know any other transformations? Reflections, rotations, dilations. Okay, we're going to do translations today. So the type of transformation we're going to do is a translation. Anybody know what this translation is? It's where you, and it doesn't even have to move all the way over to another quadrant, but if we call it, anybody know like the word that kind of is associated with the translation? Is it a turn, a flip, a slide, or what? It's a slide. When we translate, we slide it. Okay? So we're going to do some translations, and so here's what they want us to do with that number 1. They want us to move the square a distance of 10 units from quadrant 1 to quadrant 1. Okay? Is it in quadrant 2 right now? Okay, let's label those again. Let's do what like we did yesterday. This is quadrant 1. This is quadrant 2, 3, and 4. So right now, the square is in quadrant 2, and they want us to get it to quadrant 1. So we're supposed to go 10 units. So what direction are we going to have to go? Are we gonna go over or up and down? We're going over. So we need to go over to get over here to quadrant 1. We need to go this direction from quadrant 2 to quadrant 1. What should change? Both the x's and the y's, if we're gonna move it 10 units?
Only the,
Only the actual.
yeah.
Yeah, only the x's should change, shouldn't they? So let's go over here and fill in what we're gonna move. We're gonna move 10 units. What direction?
Right.
To the right. If we're gonna move to the right, that means we need to change the x values, don't we? So we're going to take the x's and we're gonna add 10 to them. So we need these guys right here. Underline those guys. Those are the ones we need. We need that -8 to move 10 units to the right. We need that -4 to move 10 units to the right. That the other -4 and that other -8. So and this is how we label the new location, A prime, that's called. Look how it's like A to the first power. It's set A prime. It's point A transformed. So let's go over here to the side of the table. Let's do this. The x value is -8. We need to add 10 to that. What is -8 plus 10? -2 or +2? +2. So our new x value is going to be 2. And when we move to the right, does the y change? Do we go up or down? Nope, so the y is going to stay 6. Okay, I want you right now just to go plot that point on that graph right now. That point, let's make sure we did it right before we keep doing it mathematically. So go plot ordered pair 2, 6. And then I want you to count, and I want you to put this by it, A prime, and its ordered pair name, which is 2, 6. I want you to count now and see, did that point move 10 units to the right? No? So start at point A and count how many units it takes you to get to A prime. Did it move 10 units, right? Okay, well then, let's go back and get the other ones, and then we'll come and graph them and see if we still have a square, okay? Okay, so we're gonna take the x value, -4, and what are we gonna do with it? Add 10. -4 plus 10. 6, okay? So our new x value is 6 for B, so our B prime is going to have an x value of 6. What's its y value going to be? 6 also, because the y is not going to change from the original point. Let's not go graph it yet. Let's wait until we get them all. Okay, the next one has a -4 for x also. Well, we already figured that out, didn't we? -4 plus 10 is? 6. Does it make sense that two of them should end up in with the same x value? Yeah, because they start with the same x value. They both have a -4. So this one is at 6 what though? 2. It has a y value of 2. Only the x's are changing. And then we have our -8 again, plus 10, which we already said is 2. So D prime has a new x value of 2. What's its y value? 2. Okay, so we're going to go plot those 3 points, 6 ordered pair 6, 6, call it B prime, label its coordinates on the graph, C prime and D prime. And let's see if we still have a square. That looks like it slid 10 units over. Oh, I'm gonna pass out some rulers so you can draw a nice square. Hopefully you can draw a nice square, you get your 4 points plotted. Okay, after you have your 4 points plotted, see if you can make a square out of it.
16.
You flipped the library label.
Hmm? Oh, I flipped them, didn't I? Thank you. Good catch there, Harley.
Like what they are.
Don't want that. They need to have their correct new names, D prime and C prime. Okay. So does it look like you have a square that moved 10 units to the right?
Yes.
Okay. We just did a translation of 10 units to the right. So A prime, B prime, C prime, D prime has its own sets of coordinates. That is a transformation of square ABCD. Okay, questions? Did we end up in quadrant 1 like they told us to? It says quadrant 2 to quadrant 1. Did that happen? Okay, we want to check all that stuff out. We don't want to just assume we did it, okay? Okay, let's go back then and let's take a look at what they want us to do with the shape in number 2. What is the shape in number 2? Triangle. Okay, so we should have 3 vertices to move. Okay, it says move the triangle a distance of 5 units from quadrant 4 to quadrant 1. Let's label the quadrants on our graph again. So 1 starts here, 2, 3, oops, I don't want it there, and 4. Yep, there it is in quadrant 4. And where are we supposed to move it to? Quadrant 1. Okay, so we're supposed to go up with it, huh? Has to go from quadrant 4 to quadrant 1. So we are going to, whoops, went the wrong direction here. Okay, if we have to go up, and it says 5 units, so that's the first thing I always want to figure out. What do I have to do? I have to move 5 units up. What would change? The x's or the y's? The y's are going to change this time, aren't they? So that means we're going to do y plus 5. Moving up 5 means change the y by adding 5 to it. So we need the y values this time, to which we will add 5. -1 plus 5. 4. -4 plus 5. 1, and we got that twice, don't we? So we're taking the y values this time. The y's this time, not the x's, because we're moving up. Up is y. So the x values, do they change? No, the x values are staying what they were. So we'll just do this, I'll just do this right away so I don't mess up. My x's are all going to stay the same. 4, 1, and 7. These are my new y values. Okay, after you have those, we'll plot those 3 new points. The A prime, B prime, and C prime. Go put those on your graph. And use the ruler as a straight edge to hopefully create another triangle. The other way you can do it is you can transform it from the triangle on the graph actually move every point up 5 points, figure out what the new point is, and see if it matches what we have in the table. That's another way to do it. Please remember, after you do plot those points, don't forget to label them. And then does it look like you have a triangle that moved up 5? What David's about the next question we'll answer. Wait, is it about this one? Oh, okay, then you wait. Okay, questions on this one, number 2. Ready to work? Yeah, did we do well? Did we end up in quadrant 1 like we were supposed to? Yes. Okay. If we don't end up where they said, then that's a problem, isn't it? Okay. If you're ready to move on, I want you to see if you can fill in what we need to do for number 3. If you can figure it out yourself, what needs to be done. Remember, put the numbers in your quadrants on your graph. We'll get you started. And then see what do they want us to do. This is, by the way, this is the poor looking Roman numeral 2. I'll make that look better. Everybody fill in the blanks on that one. We'll see if we all agree with what we're going to do here. Oh, jeepers. Lots of going back and forth here and getting nowhere. Okay. Move the trapezoid a distance of 8 units from quadrant 2 to quadrant 3. Fill in the blanks. Move how many units and what direction? And what would be affected? Which coordinate would be affected and how? Okay, who thinks they know how many units we should move and what direction? Danny? Pardon? I just answered my question, don't tell me it doesn't work. You're already ahead of me, so what quadrant are we supposed to move from? Danny, you're like, see, that's why you need to stay with us. You're not labeling your quadrants like you're supposed to. Okay, anybody want to share with us how many units we're going to move and what direction? Harley?
8 and down.
We're going to move 8 units down, okay, because quadrant 2 is above quadrant 3, so we have to go from quadrant 2 down to quadrant 3, 8 units. Okay, which coordinate is going to be affected?
Y.
The y is. What are we going to do to our y value? Do what? Add or subtract? We're going to add a negative 8, yeah. Since we always change subtraction to add the opposite anyway, let's just go with y plus negative 8. We need to move down 8. So we're going to take all of our y values, those are the ones that are going to be affected, and we're going to add a negative 8 to each of them. But in reality, our brain only has to work a couple of times, right? 6 plus negative 8, what's that? Negative 2. So that means, again, our X values are gonna stay the same, they aren't gonna change them, I'm just gonna copy all those down right away, so I don't make the mistake of changing them. All the X values stay the same, we're not doing anything to X. The Y's are gonna change, we figured out that for A prime, our Y value is gonna be -2. For B, what's our Y value gonna be? -2. For C prime, what's it gonna be? -4. And what's it gonna be for D prime? -4. Okay, so there's all of our ordered pairs that will help us create the transformed trapezoid. Don't forget to label the points and give them their ordered pair names on the graph also. And then see if it looks like we did what they asked us to do. Which quadrants are we in? One, no, that's not one. I'll label them. Oops, wrong. Oops, wrong thing. Making mistakes up here. Because I can't see my other paper like you can. Okay, did you label everything? Does it look like our trapezoid just did a downward? Did it go down from quadrant 2 to quadrant 3? So again, all these things are important. Everything we did in this is important, and that's what I would expect in the homework also. Label your quadrants. Decide what you have to do. Show which coordinate's going to be affected and how. Show getting that new coordinates location. And then being able to plot it and label it on the graph to side. Okay? Do not put those notes away. No. Leave them out. Anybody have questions? Okay, when you are ready to staple your notes, you're done with your notes, you make big to a stapler. There's one right here in the middle of the back of the room on this table, there's one on my desk. Staple your notes together. Make sure all the holes line up because they are all 3-hole punched.